So I got this CFL Tube out of my mom's sewing machine while repairing and upgrading it to LEDs. Since I didn't know how to dispose of it correctly because of, mercury and stuff, I just kept it in storage for a while. But then I got recommended this amazing video by Julius Makes and it gave me the idea to start project CFLamp. In his video, Julius already had a fitting driver for his CFL, so he didn't have to worry about it. But I don't. So after some quick research, I ended up with this, a CCFL inverter, usually for those illegal angel eye mods on old BMWs, but it should work just fine. To make sure, let's just order and test it. I guess I don't have to order it anymore. So let's just test it. And now when I connect the power, ooh, look at it. It looks amazing. I love it. And when I change the input voltage, it even dims the lamp until it only partially glows. I also found this weird phenomenon with only one lead connected, the brightness is dimmed over the length of the lamp. With the lamp working, we can now define the project requirements. For the electronics, I want the lamp to be USB powered and also to be dimmable. And since it will become a decor object, I want there to be an easy way to change the colors of the base. The heart of the electronics is this generic step-up converter, as the 5 volts provided by the USB are not enough to power the driver and wouldn't allow for any dimming. The step-up converter sets its output voltage using a voltage divider. The one I got uses a setup like this, made of a 100 kΩ potentiometer and a 2.2 kΩ resistor. With just one resistor, this design only determines the converter's maximum output voltage, while the minimum voltage can be as low as the input voltage. The output voltage Vout is always adjusted to ensure the reference voltage Vref remains at, let's check the datasheet, 0.6 volts. The datasheet also provides the formula to calculate Vout. For example, if the potentiometer is set to position 1, we get R1 is 100 kΩ and R2 is 2.2 kΩ. We can insert all values into the formula and then calculate the theoretical maximum output voltage, which should be around 28 volts. A quick test confirms that. For easy control of the brightness, I am using this 10 kΩ sliding potentiometer. With dimming, the lamp driver requires a voltage range of 6 to 12 volts. To achieve this, we need to add a second resistor to the generic setup before the potentiometer. Now to calculate R1 and R2, two formulas are required. If Vout is 6 volt, the potentiometer is at position 3 and we have to add its 10 kΩ resistance to R2. If Vout is 12 volts, the potentiometer is at position 1 and we have to add its 10 kΩ resistance to R1. With these two formulas we can do some quick calculations and find that the values are 180 kΩ for R1 and 10 kΩ for R2. Those values are already generic resistor values, so we can just grab those and build the divider. Let's plug the USB in and see if the theory works in practice. No? Maybe? Time for troubleshooting. After fixing some bad connections, we now have a perfectly working USB-powered dimmable lamp. For the base of the lamp, I definitely didn't forget to record and just want to show you this cool animation. The base of the lamp is designed in two parts. The top cover is quickly interchangeable for a different color. The bottom part houses all the electronics. Now let's send it to the 3D printer and assemble the first prototype. Yep, I broke the CFL tube while trying to assemble the first prototype. It was the only one I had. Here you can see all the parts it shattered into. Will this be the end of Project CFLamp? Probably.